Thanks everyone for being here, and it's awesome to be back here at Spring 1. My name is Ray. I'm a developer advocate for Google Cloud Platform. What that means is I love to bring some of the latest and greatest technology that Google Cloud has to offer, but also the open source projects that Google has been open sourcing in the past couple of years, like Kubernetes, ECL, gRPC, a lot of awesome tools, and we're going to talk a little bit about some of them today. And let me just see a show of hands. How many people here are using Spring and Spring Boot? Wow, yeah, I'm in the right place. Good. So and anyone here use GCP or tried Google Cloud before? Yeah, some people. Yeah, awesome. Yeah, so if you haven't tried it or if you're using it, just know that we do have a project called Spring Cloud GCP. We have really, really good idiomatic integrations with Spring Boot so that you can get a lot of out-of-the-box functionalities when you add these dependencies. Check out the project. We're going to be at the Google Cloud booth. We have a booth out there, and you can come and talk to us. We have the entire engineering team there who works on this, and a few other things. So please come to the booth after the session. If you have any questions about this session today, you can find me on Twitter. It's probably the best way to find me, and you can direct message me. And if you want to see more information or find more, more materials, you can go to my website, which is satinism.me. Now, aside from technology, I love to travel. I love to take photos. Unfortunately, I lost my camera a few years ago. But when I had it, I love to take photos. And about 7 years ago, I decided to leave my previous job. And I decided to go on a trip, a 4-month backpacking trip. That was awesome. I was in Asia, traveling around, like, say, Mongolia, China, and Southeastern Asia. And there was one city that I stopped by where I couldn't really find a cheap place to stay. Everything there was really expensive, and and I asked around, like, hey, what do I do? Like, I was scouting out parks and public spaces I can sleep outside for free. But then somebody told me, hey, if you take a bus to a desert, and once you get off, if you walk for 4 hours in southwest direction, very specific, 4 hours, you're going to find a real oasis. And by the oasis, you can sleep there for free. And I heard the word free. I asked, which bus do I take? This is the photo from the desert, about 2 hours in. You look around front and back. There's nothing but sand. How many people here walk in the desert before? Hike by yourself? By yourself, there's always a few. But, oh, yeah, there may be a few. Yeah. But you all walk on the beach, right? On the beach. Yeah, everyone walk on the beach. It's not the same, just so you know. It's completely different. As you can see here, when somebody tells you to walk in the desert in a specific direction for 4 hours, it does not matter what's in front of you. There are all these sand dunes. You just go up and down, because if you go left and right, maybe I'll just overshoot by a few degrees in angles. I might not see the oasis. I might not be here today. So you just go up and down, and the sand is actually soft. So every step that you take, you kind of sink in a little bit. You have to pull yourself out and take the next step. It's really hot and dry, and I was thirsty. I got my pack with me with the tent. And you're walking along the way, and we're just like, oh my goodness, what am I doing? This feels really tough. It feels like writing a J2EE application at work. But I left my work just so I don't have to deal with it. So anyways, the long story short, as I'm thinking more about this, that's why this photo is very special to me, right? It doesn't really matter what technology we're using today or tomorrow. It doesn't really matter which framework we're using or which platform we're trying to deploy to. But the road to production is usually, not straightforward. It can be somewhat difficult. And I see part of my job is to help you to avoid some of these difficulties. And that's why I'm here today, that I talked to some of our customers and other people using Kubernetes and folks from the Java community. And I learn a lot from them and also help implement some of these things as well. And I'd love to share some of these tips and tricks and practices to you so that you don't run into many of the issues that you may actually see when you are trying to adopt Kubernetes. Okay? So about 4 years ago, I think at Spring 1 is when I actually presented Kubernetes for the first time at this very conference. That was pretty cool. And it's been 4 years, and this year I think I'm starting to see a lot more implementations. How many people here are in fact using Kubernetes today? Wow, everyone in production? Okay, so half of you are trying to get there, and some of you are in production already. Everything I talk about today you may already seen it when you go to production. So for the rest of you who haven't gone to production, just keep these things in mind, because you'll definitely hit it, and you'll be like, oh, yeah, I remember that talk, and yeah, that's exactly what happened. I'm pretty sure that's going to be the case. I was at Code 1 a couple weeks ago. After my talk, this one person came up. He said, we hit everything that you said in the slides. So just keeping that in mind, OK? So before we go into Kubernetes, I think one of the first things that I learned when I talked to all the people using it, there are always these two camps. There are going to be a camp of folks who says, I love Kubernetes. It's the best thing ever. And there's another group of people who says, nah, it's too hard, right? And what I try to figure out is, like, what is the difference between these two groups? And I think all it starts with is with your app. And the thing I'm going to say is, when you're developing your applications, don't start with Kubernetes. Right? It's your app. You got to follow basic application best practices, best designs. Right? There are all these stuff that you have to follow. Like, for example, it's nicer to have a stateless app. Right? You got to have some kind of lifecycle that you can hook into, so you know when the app is started and when you should be shutting it down. And there are all these things that you should follow. And I'm not going to go into detail on how to best design your app, because it doesn't really matter where you deploy it. Today, it could be Kubernetes. Tomorrow, we don't know what that is. Yesterday was, Cloud, like Mesosphere. Maybe you were using Cloud Foundry, and also, before that, something else, like just VMs. We don't know. And your app should not, be so dependent on the platform that you're trying to deploy to. That being said, some of the practices are, well documented. It's probably one of the most popular one, which is 12-factor app. How many people heard about 12-factor apps? Awesome. How many people implemented all 12 factors? Wow. A few people have. How about 10? No? 5? All right, there you go. 1. Everyone should have 1. Why? Because number 1 in 12-factor app is checking your code. Yeah. So just want to make sure that you have done that already. So everyone should have at least 1 factor here. That being said, why do I bring this up? Because all the things, all the tips and tricks I'm going to talk about today, a lot of it kind of goes back to some of the principles that define 12-factor app, like externalize your configuration, port bindings, concurrency, being able to be stateless, and being able to scale out, scale in really well. That all depends on your app, right? There's nothing else Kubernetes can do for you except that your app is well behaved. So start from there. That's probably the number 1 thing. The second thing is that when I talked to a group of people who are using Kubernetes in this unconference session a couple months ago, the people who really, really enjoyed it says that, you know what? When I'm developing my app, I really never use Kubernetes during that, especially during testing, right? You don't want to go back to the cluster and redeploy your app over and over again just to see things come up. And I think that's kind of the practice that we were doing, I was doing personally a while back, right? I want to see everything. I want to see the UI. I want to try things out. When we should be really writing unit testing, right? We should be able to run a test locally as much as we want without the actual environment. So this will, prevent you from having to deal with a lot of the nuances of, a runtime environment before you even get there, right? You want to make sure your app works well, and especially if you're using microservices, make sure you just, you don't need your service to be up and running that you depend on in order to test things, right? You should be making sure that you are mocking your services, or you want to do integration testing. You have wire mock. You mock over the wire with the request and response. And since we're all using Spring here, use something like Spring Cloud Contract, where you can use a DSL to define these mocks, and then they can generate it for you, and you can just test it really easily. In some cases, you might not be able to pull in these mocks, and you have to test against something that's maybe not in the JVM. So for example, maybe you want to do a real test against a SQL database, MySQL or Postgres or Redis, in which case maybe you do need to pull down those binaries. And in the past, what we do is we do apt-get install, or we install the actual binary on our app, on our machine, and hopefully all the state is fine, and then we run the test, and then we say, oh, that failed because the test was not updated. Well, there's a really cool utility library out there. It's called test containers. So if you ever need to do unit testing against some components that's not in the JVM, if you can pull it down from containers, use test containers. You can do all of the unit testing directly just on your machine. This is really, really neat. It will download the container for you, bootstrap it for you, and then during the lifecycle of your unit test, everything's up and running. And then when your test is done, it shuts everything down for you. You don't even have to run Docker locally. Okay? So I think those two things, or fundamentally the defining things between people who really enjoy Kubernetes and its deployment, and then developers who found it a little bit hard to use. Now, once you have your app designed properly, then let's go ahead and containerize. And this is where we have a lot more things to discuss. Because in the past, when I was developing for a enterprise environment, the environment is usually controlled and locked down by another group of team. And then every time that I said, oh, I wish we can use the new JDK, or if I need certain things to be installed, it will take a long time for that to happen. And now with Docker images, we are in control to some extent. The amount of binaries we want to install, right? We are in control of that runtime environment. What that also means is that with that power, it's also our responsibility to make sure that our images are well done. So what that means is that we need to make sure there's no vulnerabilities. We need to make sure that the environment is fine and sane, and we gotta keep everything up to date. And we have to apply best practices there. Now, when we create a container, the first thing that we are going to do is to think about what JDK version to use. It's getting ever more so increasingly hard, but I'm assuming everyone here who are using JDK 5? No? JDK 8, Java 8, of course. Yeah, almost everyone. Anyone on 11? Wow, a lot more than I expected. According to survey, about 20% or more is using 11. 13, bleeding edge. Not yet. Oh, 1%. Very cool. Yeah, but if you're running JDK 8, for example, do you know what specific version of JDK 8 you're actually running? No. Yeah, some people do. You should, because only certain versions and above is actually container aware. Yesterday, some person came out to me and said they have this issue with out-of-memory issue in the containers. And my first question was, what JDK version are you using, especially if you're using JDK 8? And we don't know, and that's usually where the root of the problem comes from, because only 8U192 and above is container aware. What that means is that if you use anything lower than this, you either have to enable it explicitly, or there's just no container support whatsoever. What that also means is that if you don't specify any max heap configuration, the JVM is going to see the memory that you assigned on the host, on the physical machine, as opposed to the amount of memory that you assign to the container. So I'll give you a quick demo of this. It's pretty easily reproducible. So if I want to see max heap, and I want to use an older version of JDK. Okay, so here we are using Docker run. I'm setting the memory to 256 megabyte. I'm setting the CPU count to 2, and this is how much CPU my application can use. I'm just going to run the JVM, and I'm going to exit very quickly. And I'm going to print the final flags. I'm going to see not the thread, but I'm going to see the max heap. Now, you would imagine if I have 256 megabytes of RAM, my heap will be like half of that. But if we see this in an older version of JDK, it's actually that. And I have no idea what that means, because every time I have to go Google it. Let me see here. So you can do that bytes in GB. And it's actually 27 gigabytes. What happened is that when we're creating these containers, we usually don't hardcode the XMX. We don't hardcode the max heap into our container startup command line. That's actually pretty bad. But then at the runtime, when we should be specifying it, we usually don't specify it either. We may forget. In which case, if you're using the wrong version of the JDK, you're going to see it's going to consume a lot of heap. And with 27 gigabytes of heap in a 256 megabyte memory limit, you're going to run over that very quickly, because GC is not going to kick in until you get even closer to it, and you're going to get OOMKilled right off the bat. This happens a lot, and especially when you are not using the right JDK version. Now, more specifically, though, another really big issue that people don't usually see immediately, but maybe see later, is the number of threads that the JVM thinks that they can have. So if I were to look at, because it's using parallel GC, if I were to look at the parallel GC thread, if I scroll up a little bit, there it is. Even though I assigned it with 2 CPUs, the parallel GC thread is actually 13. That's also because the JVM is not container aware in this particular version, and so it's seeing 16 CPUs on my host, and it's using 13 of them for my GC thread. Now, what is even worse about this is that a lot of times we try to initialize our thread pool with some kind of default size of the thread pool. And the way that we do it is usually we do it with the number of CPUs that we have. And so the way that we do it is by using runtime get available processors, right? And that should return you how many CPUs you can actually use. In the JVM that is not aware of the containers, it's going to tell you have 16 cores or 32 cores, and your thread pool will be severely over-provisioned for the number of cores you actually want to run. Okay? Now, here's the side effect of this, which is the amount of memory that is actually being used. Remember, in the JVM, it's not just the heap that you use. You also spend native memories is being used based on the number of threads that you have. Right? There's a stack size that you can set. By default, it's 1 megabyte. And if you have, say, 30 threads, just the memory, native memory used by the threads is going to be 30 megabytes. If you think about Tomcat or something else that has a max thread pool of 200, that's 200 megabytes right off the bat, right? In addition to the heap that you actually need to run your app. So be very careful with this, right? Now, if you actually do this with the right JVM version, if I were to go back to the max heap, and I'm going to use one of the newer version here with AU222. If we see this, the default is going to be a little bit more sand. It's going to be about, that is about 132 megabytes. Okay, there's a huge difference. That's the difference between you get OOMKilled within like 2 minutes versus, say, within a week. Just kidding. No. No, we restart our app before that week is up, right? So it's fine. Right? And similarly with the threads, you're going to see the right values. That being said, how do you actually know how much memory you should actually have? Well, you should profile your app, right? You should really run it and understand it. Cloud Foundry actually has a really, really awesome calculator. I didn't know this until I talked to the Cloud Foundry build pack folks, especially Ben Hale. He said, well, we actually have a memory calculator. This is pretty cool. You can feed in some basic information, and it'll tell you like what is the max heap and other parameters you can set. Now, you should definitely check it out if you haven't used this before. And basically, the amount of memory that you can use, that you can configure, is basically a function of, well, first of all, number of threads, because the more threads that you have, the more memory you're going to use. And secondly, it's pretty much parallel to the number of classes you have. They've done pretty good studies here. So if you feed in this information and the amount of memory configuration that you have for your overall size, it can give you a pretty good JVM argument that you can use as you're configuring your app. Okay, so let's give it a try. I don't know if I have this queued up somewhere. Oh, there we go. Java build pack memory calculator. It's supposed to have 1,000 classes with 100 threads. My Docker container, I set it to 512 megabytes, and this is my stack size of 512. Because if you set it too low, you're going to get Stack Overflow. If you set it too high, you're just wasting memory. So you have to figure that out. And this is the type of information you can use. And then you can set it into the Java, the options or something like that. And you can override these parameters as you are deploying your app into different environments. Okay. Now, in some cases, which I kind of ran into before in another containerized environment, I'm just getting OOMKilled left and right. I don't know why. I thought I followed the best practices. I really don't know why and what is actually using all the memory. In that case, in the JDK, there's actually a really nice argument you can add. It's called native memory tracking. So if you really want to know how much heap and how much native memory is being used, because that's the thing that we don't see, right? We will not go over the max heap, but you don't know how much native memory is being used. And so if you add it into your JVM startup command line, at the successful exit of your application, it'll give you a printout of the memory breakdowns. Now remember I said successful exit. What that means is if you got OOMKilled, you're not going to see this, right? So if you want to test it, you want to give it a little bit more memory, make sure it doesn't get killed, and then you shut it down successfully, and you're going to see some really interesting data. And this really helped me in the past as well to figure out like what is actually using the memory. Because sometimes we have like direct memory mappings. Some of the cache, they go straight to the native memory. Like we got to kind of figure it out. So anyways, so here are a few things that we can enable, like native memory tracking. And then we need to print the native memory tracking statistics. Okay? And this only works if you add it directly to the JDK command line. It does not work if you try to configure it over the environmental variable. I don't know why. It didn't work for me. And it took me a while to figure out, oh, let me add it back to the argument. And it actually printed everything out for me. Okay, so if you do it this way, if you look here, we can clearly see the Java heap, class, threads, code, garbage collector, right? There's a lot more than just a heap that we need to spend memory on. And this will give you a pretty good idea of what is it that's being used. That being said, in most cases, like the native memory usages are pretty static. So given an app, it should be, whatever that is, like it will be the same no matter how much more memory you give it. And the rest of the space, you should dedicate that to the heap. Okay? And then once you figure out what JDK version you're using, that you should be using, of course, the newest is possible, then we need to create the container itself. Now, I have just a 1 whole hour talk about how to best create your container image with a Dockerfile. And typically what we do is we create a Dockerfile, we say from OpenJDK blah, and then we say copy my jar into this directory, and then entry point java-jar, my jar, ship it. That's not enough. There's a lot more things that we have to do. You can check out this talk for more details. But these days, though, I say, you know what? There's actually a much, much easier way, which is to just Jib it. How many people here heard about Jib before? Wow, nice, awesome. If you haven't used it, this is probably my favorite plugin so far for creating containers. It is a plugin that's being created by Google. And the team is actually here today as well. You can find them in the booth. And this is a plugin for Maven and Gradle, where given a Java application, given a build file, we can automatically build the container for you. So you don't need to write the Dockerfile anymore. And you apply some of the best practices, especially the one around the image sizes and layer. Okay? What do I mean by that? Well, first of all, let's go ahead and add Jib to this. So I'm going to go ahead and just build this application. And I'm going to add a plugin called Jib. Okay, I got a shortcut. That's fine. And basically, you got I'm using one of the latest version. All you need to do is to give it the image you want to build to, right? Usually, we say Docker build, and we Docker tag it, right? And now this in Jib, you just give it the destination that you want this to build to. And then if you want to, like many companies, maybe they have a corporate policy, you need to use certain base images, right? So you can also say from, and I can specify the base image that I want to use instead of the default one. By default, Jib uses distrolist. It's a container image that Google maintains, but it's really just using the Debian OpenJDK distribution. If you have something you want to use for yourself, right, from your company, you can just configure the from image. And to do that, what we're going to do is I'm going to use the OpenJDK one. Let me see here. I'm going to use the 8U222 Slim. Okay. And that will configure the container to use that base image. At no point do I touch the Docker file. In fact, Jib will work even if you don't have Docker installed locally. And some people really like it, also in the CI/CD pipeline, because then you don't need root, you don't need anything, you don't need Docker daemon. You can just say maven jib build, and it will build the container image for you. Another really good thing to think about before you even create this container is, well, first of all, what is this? Do you trust this container-based image that you just referenced to? If you do trust it, the second question is, what is the user that's going to be used to run your app? As long as I've been in IT and as an engineer, one of the first things I learned is don't run your app as root. Just don't do it. No matter what environment you're in, just don't run your app as root. How many people here know what user you're running your Docker containers with? Yeah, OK, about a third of the room. The rest who may not have checked, it's probably running as root, right? Because by default, all of these images are running your app as root. Even if you're in container, container is not a security boundary. So please do not run things as root. And unfortunately, most of the images will run it as root. So you do need to kind of figure out what user you want to run as. Why is this important? Because as you go into anything beyond, say, test, say if you're going to staging pre-prod or prod, the operations team will be asking, what are you running your container as? As root. It's like, oh, no, we've got to fix it. And they're going to apply Kubernetes security policy to say, don't run as root, run as another user, read-only file system, and then potentially your app may not start. So I actually believe it's much, much better to figure this out early, just to run it as a non-root user that has no access to the disk, so you can figure out all the issues as you are developing your app. Okay? And here's the thing. Every container, they may have different non-root users. So you really need to understand your base image. So for example, if I were to see here, Bing Bash. So if I were to get into this container image, I'm going to see what users are in this OpenJDK 8U222 image. I can just run the container. I can get into the shell. I'm in the container right now. And then I can see the Unix etc password, etc passw. And there's a nobody user here. And one of the things I do tell the team who are implementing some of these things and run as non-root is, don't use any users IDs that's under 100, because that's usually the system UID. And also don't use anything that's under 1,000. That's usually installed by the distribution. And then and usually there's a nobody. Just find out what that ID is. Okay, so there's always a nobody. And then there's always a no group or something else that doesn't work. So make sure you have those two things. If it doesn't exist, you should create a container that has a non-root user. So if you want to configure this, we can go ahead and use container tag here. And then we can say the user is nobody and no group. Okay? So these are the three things I would recommend people do when they're using Jib. For demos, if we do just 2, that's enough. But then if you want to make it a little bit better, just make sure you got your corporate approved base image, and then run it as a non-root user. Okay? And then we can just go ahead and do a compile, and we can do Jib build. Now, what this will do is to analyze your build file. It will know what the dependencies are in the runtime environment. It will actually automatically do the layering for you. What that means is that rather than publishing a giant 80 megabyte, 100 megabyte jar in a single layer in the container, it will actually understand, well, most of it is dependency, so I can put in a layer that doesn't usually change. And then your resources, the property file that changes frequently, I'm going to put in a separate layer. And then your application code, which is usually a few kilobytes, 100 kilobytes, we're going to put in a separate layer. So it will automatically split your application up into multiple layers. Whenever you make a change to your app, rather than recreating the whole thing, you'll just swap out the layer that has the new changes. Okay? So that's why when I did this build, it was actually super fast. Right? It also pushed directly to the registry. So in my case, I'm using Google Container Registry, and I just configure that. I configure the credential. I say Jib build, and it builds directly to the registry. If you are working with a local Docker daemon, you can say build Docker, and that's going to build the image into your Docker daemon as opposed to a remote registry. Because some corporate, if you're lucky, you have a registry you can use. If I'm just working by myself, I will just be working with a Docker daemon. So we can work with both ways. Okay? So just Jib it is probably the easiest way to create your container image. It applies many of the best practices, and you just want to make sure you follow a few other ones like ping your versions and make sure it doesn't run as root. Once you have your container in your app, a few other things to just double check is just make sure your app does not write to the file system, especially the logs. And if you're using Spring Boot, you should not have many issues. But if you're packaging your own Tomcat or WebLogic or something else, right? Most likely, those app servers will be writing access logs or std out to a log file. Now, the problem with that is that in container environment, we don't have any log rotators. There's nothing on the system that knows you're writing logs, and we're not going to rotate them out for you. So it will just accumulate over time. You'll have a bigger and bigger and bigger log file over time until you, how many people here restart JVM every week? Yeah, a few people, yeah. Until you restart your JVM. But if you run your app for a month, you're going to have a really big log file. So just be careful with that. Just don't write anything into the log files, okay? And finally, this is part of the 12-factor app. Just make sure that you are able to configure your app via external sources. I know that in Spring Cloud, there's a Spring Config server, right? That's something you can use. But I think for me personally, in the Kubernetes environment, I like to configure my stuff via the environmental variables or being able to mount a application.properties files via configuration map so that I can, via configuration, I can configure my application really, really easily. Okay. So that was just before you get to Kubernetes. All right. So now, what do you do once you get there? You got your container. You know what you're running. You're following best practices for your apps. You're not running any logs. Now we can kind of try to deploy it. You run your test. You run your unit test. Everything works. But of course, we're curious. We always want to run it in the environment and see if it actually works. And so here are the things that we can do. The first thing that I think is pretty important as a developer, when we're trying to write these deployment descriptors for Kubernetes, I would say just keep it as simple as possible, right? You don't need 2 instances or 10 instances running. Just run 1 instance. There are only a few basic things that you should care about as you're running this in a development environment. We're going to get into that in a second. Okay? So here's my Spring Boot application. And in Spring Boot, of course, if we reference anything by value, like with this expression, we can override it in application.properties. You can override it in environmental variables, or many other ways we can override this value externally. So that's really nice. So we are covered in that respect. We have nothing in the configuration right now. That's fine. I built my container using Jib, right? Pretty straightforward. So let's go ahead and deploy it into the cluster and see what's some of the practices there. So there are two ways to do it. I'll show you the bad way that you should not do. Okay, so basically you say kubectl. Old version, you say run. The new version, you say create deployment. And then you say demo, and I'm going to say demo app. And then you give it the image name. And I'm going to copy and paste this. Okay. And then you hit enter, production, done. No, don't do that. Right? Why? Because in Kubernetes, I think one of the things we really need to think about is to codify your deployment. You want to be able to declare the states that you want. Let Kubernetes deal with the reconciliation. If we always do things on the shell scripts like this one, if you need to deploy 20 services, you'll end up writing a shell script that deploys everything for you again. And that is not the way we want in Kubernetes. What we always want to do is to check in the descriptors, the declare state. And I cannot stress this enough. Even if you're using CI/CD. A lot of people, when they're using CI/CD, they use kubectl rollout update, something like that, to replace the image. Please don't do that. Like in CI/CD, what I say is, please check in your YAML file. So if you make a change to the image you are trying to deploy, you retag it, you update the YAML file that has the new image coordinate, you check that YAML file in, and then you trigger the CI/CD to deploy that YAML file. And this has saved my customer a lot of time, because I recall that they actually accidentally deleted their cluster, and they had to rebuild the whole thing. But because everything's codified, they can back up in like 10, 15 minutes, and that was not too bad at all. Okay? So how do we make this better? Well, basically, rather than doing the kubectl create, which will run directly in the cluster, just do a -- dry run. Okay? What that means is just simulate this, don't actually run this in the cluster, and then do a o-yaml, and that's going to show you the YAML file that will be actually sent to the cluster. And this is probably one of the easiest way to generate the YAML file that you can then use. Now, there are other tools out there like Fabricate and Decorate. There are all of these different ways for you to generate the YAML file directly from the app. I'm on the side where I want to touch the YAML file myself, and I want to create it myself. And this is the best way for me to bootstrap something very, very simple. Right? Remember, keep it simple as possible. And we should be outputting it to a directory. Usually, we put it into, say, KS or Kubernetes. Okay? So I'm going to do this OYAML. I'm going to output this into deployment.yaml. Okay? That's just one thing. And then, of course, I want other people to be able to access this application via a load balancer, via a DNS name, via service discovery. In Kubernetes, we have the built-in service, right? So rather than using like a service registry, something else, we can just depend on Kubernetes service registry to be able to look up my application and be able to connect to it. To do that, we can create a service, and the same thing we can do. We can do kubectl create service. Now, there are many different types of service we can create. Cluster IP, which is purely internal. That's mostly what you probably want. If you want to expose something publicly, you can add a load balancer, or you can use an ingress instead. So I think for most people, cluster IP is the right choice. Just make sure your service is accessible from internal only. So we can say kubectl create service, cluster IP, the demo app, and then I think it's TCP. So I need to tell it which port I want to listen on. So the load balancer will be listening on port 8080, and it's going to forward to the port 8080 in my deployment, in my application. And I can do the dry run again, and then do OYAML. Okay? And that's going to give you the YAML file for the service. And now you can enhance it a little bit more. So I'm going to go ahead and output this into service.yaml as well. Okay? All right. So once I have everything created and checked in, what I can do then is I can, of course, go ahead and do a apply. Right? This is the best way to do it. Always know what you're deploying from the YAML file, and then you apply it to Kubernetes. And then we should be able to see this up and running in a second. Oh, that was really fast. Really? When a demo works that fast, you just don't know if it's working or not. And I can guarantee you it was not running before. It just started 3 seconds. You can also see I ran something for 300 days so far. So that's pretty impressive. All right. So and I should also have the SVC, which is the service. And I got my demo app load balancer here with the cluster IP. Remember, this is internal only. So you can't really access it from anywhere outside of the cluster. Now, in Kubernetes, one of the easy ways to do this is by creating a port forward. So you can use kubectl. You can do port forward, like that. To what? You can port forward to a service called demo app, because that's what I created. And I think I can say, well, I'm going to bind it to the local port 8080. So that's on my laptop. And I'm going to port forward into that load balancer on port 8080 as well. Right? So I can use Kubernetes to basically create a port forwarding tunnel. And with this, now I can do I can curl localhost 8080, and I should be able to see my app working if it works. So let's see here, curl localhost 8080, and I think I got the hello endpoint, and name is Ray. Ooh, there we go. And oh, OK, that's not bad. That's not bad. So let me do the w/n. Not that one. Hold on a second, so that we can see it slightly better. There we go. OK. So remember what's happening. It's connecting to my localhost, going through the port forward proxy, forwarding it into my cluster, into that load balancer, and then the traffic is routed to my pod, right? And I can see here, I think I made a little mistake. Hi, Ray, I forgot the space. Shoot, what do I do? So this is why you need unit testing first, right? Test your stuff first, then you can save on this type of iteration. If you do want to fix it, here's what typically people do. We will go back to the code, we'll fix the code, we go back to Jib, we recreate the container, we delete everything from my cluster, and then we reapply everything, we wait for it to start, and then we check it again, right? And this cycle never ends. Every time you want to do something, you repeat this cycle, right? And this is pretty standard, and it's what usually a lot of people do. But again, if you do unit testing first, you should be cutting on this cycle in the first place, okay? So what do? Well, we actually have a tool that's really cool. It is called Skaffold. Okay, it's a command line tool that was created by Google. Again, if you use Docker, you probably have used Docker Compose before. Skaffold is really somewhat similar, except it works just with Kubernetes, and you're able to bring up all of your app using Skaffold with the YAML file definition, and everything will be up and running in the Kubernetes cluster just as easily as a Docker Compose would in a Docker daemon instead. Okay. So how does that look like? Well, first, we need to create more YAML. So let's go ahead and create a YAML file here called scaffold.yaml. Scaffold.yaml. OK. I'm going to have to do that. And then I'm going to zoom in a little bit. And scaffold, they do have the code completion here, a little snippet that you can use. So I can say scaffold, I use the scaffold config. Okay. And then here we can list a bunch of artifacts, meaning that if you have a monorepo with multiple services, you can list out all the different things you wanna deploy, right? So if you have a multi-module Maven file or a multi-module Gradle file, multi-project Gradle file, you can list out a bunch of different services you want to do. But I would prefer multi-repo if you can. Just multi-repo is so much nicer. So here I can say, well, what am I trying to deploy? I'm going to deploy gcr.io. Weiss, Coyote, 827, and Jib demo. How is that image going to be built? So in Skaffold, by default, it's going to work with Dockerfiles. So if you have Dockerfiles already, this is all you need. This will just know that I need to use the Dockerfile and use Docker to build this container image before I deploy it. And as you're editing the code, it will just rerun the Dockerfile, and it will just redeploy the thing for you automatically. But because we're using Jib, so we can change the builder to Jib builder instead. So you can just say, I'm using Jib instead, right? And then I can take advantage of this really fast build. We can also further configure what you want to pass in to the Maven command line. So we can say args. And by the way, this is only for the demo. Don't do this in your own environment, but I like to do this a lot. Only to save me time. Don't do this when you're doing your own application, please. Yeah. And then we can tell it where my Kubernetes YAML files are, right? I just created them. They are in my KS directory. So I'm going to say, you know what? I want to deploy everything that's in the KS directory, and that's pretty much it. Okay? Once you have this all configured, we can go back to the prompt, and we can say scaffold dev. And what this will do is to read that YAML file. It's going to see how many images I need to create. It's going to say, OK, how do I create an image? So I'm going to use Jib to build it. Okay? And then it's going to deploy my app into the cluster using the YAML file that I just created. Keep it simple. And then it's also going to go ahead and stream the logs. Again, don't write the logs to the file system. Write it to std out. It's going to stream the logs to my console. It feels almost as if I'm running this locally, but it's not. Okay? And now when I go back and fix things, so for example, if I go back and say, go ahead and change this to, where is this code? Oh, there we go. So I did forget the space. So I'm going to add a space in here and add a plus. What this will do is to understand via Maven build that I changed my source, and it's going to go ahead and trigger the automatic rebuild. It's going to use Jib to do that, and then redeploy my app for me, and continue this whole process for me as it watches for changes. Okay? So if you are trying to figure out how to change your YAML files, you want to redeploy those YAML files, this is a pretty good way to do it. Assuming you want to fix something really quick in your app, this is a pretty good way to do it too. Now, what is the best part of this is that, let me go back here. We do have a plugin for IntelliJ and VS Code. How many people here use VS Code? So I'm wondering. OK, and IntelliJ? Nice. OK, cool. Eclipse? OK, yeah, I used to use Eclipse a lot. But the plugin here only works with IntelliJ and VS Code. Let me see if I can find it. So if you're using IntelliJ, you can go ahead and see this. Cloud code. Huh. What? Did I misspelled cloud? Sure. All right, cloud code, right there. Yeah. So you can install it. It will work with any Kubernetes environment, and it'll give you really nice code completions as well. And I just updated it today. So yeah, for the demo, we'll see how this works. Okay. So what that will also bring you is there are plenty of additions for just Google Cloud, right? So we can deploy to App Engine and a few other places. But the thing I'm interested in is the Kubernetes support. What this will give you is a explorer, so you can explore your Kubernetes cluster, right? So if you have, like me, I got all of these are my Kubernetes clusters, by the way. I got a lot, right? So you can see the clusters here. But what's really important is you can actually use Scaffold directly in here. So on the top here, we have continuous deploy and just one-time deploy, right? So rather than going back to the command line, I can just do continuous deploy. What is really cool about this also is that you can also you can turn on debugger as well. So let me try this out. Let me see if this works well. So I'm going to hit debugger. Not on the app, sorry. I need to do it on the continuous deploy. So I'm going to go back to here. I'm going to hit the debugger here. So what this will do is to start Scaffold with debugger enabled. What that means is that it will automatically add debugger information to enable debugger in your container. It will automatically pull forward the debugger port, which is 5005, and it will configure IntelliJ to automatically attach to the debugger so that you can actually do something like this. I can add a debug point here, or a breakpoint here. And then if I were to make this call again, let me see if this works. Curl, localhost 8080. Let's see. Oh, interesting. What happened? Oh. I think one of the issues is that I didn't also pull forward properly. But if it did pull forward properly, then I should be able to connect to it, and I should be able to debug this application. Now, that's interesting, though, because pull forward should be up and running, but it's not. So let me take a look at what's going on. Because, let me stop this. When I go back to continuous deploy, if I just run the regular cycle here, let me see if this is going to work. Oh, you know what? Maybe the app wasn't running. But let's see. When I start my app, with Scaffold in the IntelliJ. It also added this additional flag called pull forward is equal to true. Now remember earlier, I had to physically say kubectl pull forward my port. Here with Scaffold, it automatically detected that we have a service, and it should actually automatically do the pull forward for me. There we go. So the port is not 8080, it's actually 8081. Okay, so I should actually go there and see my app. So I can do something like localhost 8081, hello, name is equal to Ray. Okay, and that actually went through, right? And now I can do all my edits, and things will be updated continuously. right? So if I go back to the debugger demo and I say connect to port 8081, that should also work, all right? So good so far? Yeah, it should be pretty straightforward. Let's see here. Now we have the YAML file. Sometimes we say, well, we're done. Like this is rest of it is operation stuff, but it's not, right? We need to know some of the basics that will best be used for operating your app. So a few things that we should be doing. I think there are only a few things I really want to make sure that you all do as you are editing and understanding the YAML file here. Right? So first of all, we have the name of the app. We have the replica is equal to 1 because we're in dev, which is run one instance. And then here's my container image I'm trying to run. Two things I want you to set. Number one is the resource. Okay? And resource is basically how much memory do you need and how much max memory can you actually use. And in Kubernetes, there are two settings. One is called the request. This is how much memory do you want at the minimum. This is potentially used to schedule your application so that there's bare minimum requirements. So I can say something like memory, I need at least 256 M. Now be careful here. The small m means milli. That means 1/1000th. So what this also means is that you're going to get less than a megabyte or less than a byte of memory, which is not going to exist. So do the big M. That's the power of 10. And mi, that's the power of 2. Okay? So make sure it's a big M. Because this happened to me when I did the small m, and I'm like, why am I out of memory every single time? That's because there was no memory. All right. And then CPU, I can say 2,000 milli. So again, 2,000 1,000ths. So that's 2 CPU. Now, if you don't set any max, your JVM, again, is going to see your host CPU and host memory, and it's going to set a lot of heap. If you have multiple JVMs running on the same machine, it's bound that one of them is going to be out of memory just from the system perspective, right? So it's actually pretty good if you actually set the actual upper bound, because this upper bound will then be used by the JVM to understand how much heap to use, okay? So here we can say the memory max, I want to use 512 meg. And the CPU, I need to be able to burst up to 4 CPUs, right? So that's the number one thing you want to set. Just know how much memory and CPU you want to use. The other really, really important thing that you want to set, actually the most important thing you want to set, is the Kubernetes health check. A lot of people don't do this, and what happened then is once you go into production, as you're doing a rolling update to a new version, you're going to miss connections, you're going to miss requests, because you're not taking advantage of what Kubernetes will actually provide you, which is the ability to understand the lifecycle of your app, allowing you to gracefully shut down, and also being able to hold on on connections that shouldn't be going to the instance that's being shut down. Okay? And there are actually two different checks you can set. One is called the liveness probe, okay? And the other one is called the readiness probe. There are two different probes, and they are very, very different in behavior. The way I think about it is that liveness probe is the thing that you should check and fail if restarting your app will help you recover. Okay? That's very important. You should only fail it if you think that restarting your app will help you recover the application. For example, you're running out of heap every week. No, just kidding. Don't do that. We have cron tab for it. We got cron tab. But also don't do that either. So, however, this is where you should always set it if recovering your app can be done by restarting it. What that also means is if you have dependency on MySQL, right? Because a lot of times what we do is, what do we do in Spring Boot app? We add an actuator, okay? So I'm going to go ahead and add an actuator in my dependency, actuator. And that will bring in the actuator/health endpoint, okay? And I think this will trigger my reboot, right? So I'm rebooting my app. It's going to redeploy right off the bat. And if I go back to the deployment.yaml, if I set the liveness probe to the actuator, you might actually run into issues, right? And I'll tell you why in a second. So if I do something like path is actuator.health, why? Because in most cases, by default, the actuator health check is going to be looking at your dependency services. So like, is MySQL up and running? Is Redis up and running, right? And if any one of these backend fails, this check will fail. And when Kubernetes sees it, it's going to try to restart your app. But is your app going to recover simply by restarting it? Most likely no. And if you do restart it over and over again, other services depending on your app might be triggered too, and now you have a cascading failure. So be very careful with here. I personally don't like to use the actuator for the liveness probe. It's very important that the liveness probe is something that you can check and that something that can actually recover if you restart. What I do these days is actually just create a new endpoint here, just manually, right? Just say alive, something like that, and then return OK, because there's no dependency that I need to depend on. And I'm going to say just something like alive, alive. Okay, I'm going to save that, and then back in my YAML file, I'm going to say use the HTTP GET on port 8080, and the path is called alive. As you can see, I'm doing this. It's redeploying everything for me continuously, which is really, really useful. Now, it's pretty important to keep in mind that the liveness check should actually live on the same port as the serving port. Because sometimes we put the actuator, the management thing on a separate port. It's a very good reason to do it. But then for the liveness check, you should check the port that's actually serving. Why? Because sometimes you're actually out of threads. Maybe you have deadlocks somewhere, and just your app is not serving. That can probably be recovered by restarting it. And if you put the liveness check on the same port, you'll be able to catch it. If you put it on a different port, you'll be on a different thread pool. And you're always alive even when your app is actually having serious issues. Okay, so be very careful with that. Now, for the actuator, what I do like to use it for is the readiness check, because it does tell you whether your backends are ready to and connected. So I will do that too. So I'm going to say port is 8080 and actuator health. Okay. That's the two basic things I would do. If you only have a choice to do one of them, I don't know why you only have one, but if you only have one choice to do one of them, I would say do the readiness probe. Always do that one, because that's the one that when it's exceeding, it will enable the traffic to flow through Kubernetes services and come to your service. Right? So why is that important? Because sometimes your application is starting up, it's alive, but you're not ready to serve traffic. Because you want to rehydrate cache, you need to preload a few things, in which case you use health indicator in Spring Boot. When you are all hydrated, then you turn the indicator to be OK, and then you're ready, then traffic will be flowing through to your app. Okay? When you're shutting down the app, what Kubernetes will do when they try to shut you down is to send you a signal. It's called sick turn. And you're supposed to catch it, and you're supposed to then do the graceful shutdown. Now, this is the most difficult part of this whole thing, to be honest, because there's nothing out of the box that helps you to do this. And it took me a while to figure out what the right process is. It's well documented in one of the things I'm going to show you. Basically means that what you want to do is when your app receives the sick term, people usually just shut down. But however, when you're shutting down, traffic can still come to your instance, and now you're going to get connection refused or some other issues. What we really need to do in this Kubernetes environment is that we need to fail the readiness probe. When you fail it, Kubernetes will take it out of the service from the load balancer. However, you still need to handle any ongoing request. So you got to wait for those requests to finish. And then when Kubernetes detects the failure, it's going to turn off the load balancer, right? And then you wait for everything to finish. And then after a few seconds, you then shut down. Okay, this is a very important sequence of steps. Because once Kubernetes sends you a sick term, it still thinks you can receive traffic. I don't know why. But so that's why you have to turn off the readiness probe. Okay? So here's a few tricks you got to remember in these two probes. There's one thing, it's called the initial delay seconds. So sometimes our app starts more than 30 seconds. And when the liveness probe kicks in, your app is not started. What it's going to try to do? Try to restart it. And then you're going to restart it again, and then it doesn't start within 30 seconds, and you're going to kill it again. So your app will never start. Okay? It can happen. And one of the things you can do is to set initial delay seconds. Basically, that means, well, if your app takes like 50 seconds to start, you just start the liveness probe a little bit later. Similarly, for the readiness probe, we have that. But what's more important is actually this one, period seconds, and potentially the success threshold and the failure threshold. Okay? What that means is that if you actually turn off the readiness probe, it will take Kubernetes some time to figure that out. Okay? So maybe it's 30 seconds. So you turn off the probe, and 30 seconds later, Kubernetes realizes, oh, you're not accepting traffic anymore. And then you have to spend like a minute to gracefully shut down. So you can potentially play around with this with shorter periods, and potentially if you are pretty sure that what this probe is going to respond, you can say, well, I only need to wait for one of them, or you got to play around with your app and see how the behavior is. But for the demo, I'm going to say after one failure, and every 5 seconds, I'm going to check whether my app is ready or not, right? And that's the way that we can figure out whether I should be shutting down or not. Last point here, that's very important, is, again, the Spring Boot actuator does not actually understand this readiness probe. Okay? So when you're shutting down, your health check will still be 200 success. Okay? So you'll never get your app out of the load balancer. The only code that I found that was really, really nice came from SBB in Switzerland, the rail company, I think. And they have this really neat thing. And you can probably write one yourself too. But this one is called Spring Boot Graceful Shutdown component here. I like this one because it actually implemented everything that I talk about. And I actually learned quite a bit from that as well. So what this will do is, let me see here. Let me go ahead and change this out. Because with this little starter, you actually need to change out the Spring application run. Because it needed to add some shutdown hooks outside of what you can add from outside of Spring application. So let me see here. It's called Graceful Shutdown Spring application. That one. Yeah, that's the one. Okay. I'm going to just copy in this one. Copy and paste. Yeah, there we go. Oh, come on. Yeah, there we go. Whew. And demo application.class and args. So we replaced the application runner with the Graceful Shutdown one because it needed to add more shutdown hooks. Okay. And this also comes with the right health indicators so that when you receive shutdown sig term, you will turn off the readiness check, and it will shut down your app after 20 seconds or so. Okay? So with this, you can then orchestrate what I talked about earlier, where we need to turn off the readiness probe, wait, and stuff like that. Okay? So let's see if this works. Let's see if this works. All right, so I'm shutting down a previous instance, and a new instance is being started. And later on, when I do another demo, we're going to see what's actually happening behind the scenes. Okay? All right. So very important thing to remember. Now, with the last couple of minutes, I think I'm until 3:10, right? Yeah, 3:10. Okay, good. So now the last part of it that we should all be kind of curious is, well, the YAML file that I just created is great for development. I'm running one instance. I got some of the basics in here. But when I go into higher environments like QA or staging or production, everything changes. Everything changes, right? All of these parameters change. So what do people usually do? There are a couple of tools out there that people use. Something like Helm. You can create a Helm chart. I personally don't use that. I don't like the daemon that runs with it. But a lot of people do. And then there are other things like some people write their own templating engine, like using Jinja or Python, right? They just feed it through the templates, and then they create their own YAML files that way. We finally will have another tool. It's called Kustomize. Okay, Kustomize. And this tool is able to help you customize your YAML files. And the way this works is very intuitive. It's really, really cool because there's no more environmental variable replacements or anything like that. It works like this. First, I'm going to create a new directory here called Kustomize. Let me see here. Not new file. Here we go. New directory. Kustomize. Yeah, there we go. And with Kustomize, I can give it a base set of files I want to deploy. And typically, this is the deployment files we just created. In fact, I will get rid of the KS directory, the Kubernetes directory. I will just make a copy here, and I'm going to copy it into Kustomize. Oh, I want to do a copy. There we go, for now. OK? And we're like, well, what's so different about this? Well, we can also add another file here called customization, customization.yaml. Okay? And if I zoom in here a little bit, we need to follow the API version here called customization, and kind is customize. As you can see, I got these nice auto-completion. That's all from the Cloud Code plugin. And then we can list out the resources. These are the files we want to customize. So here's the deployment.yaml. And then we have a service.yaml. This is really, really neat. Okay? Hey, there we go. And then I can potentially go back to the prompt. And if I go to customize base, I can do customize build. what this will do is to read the customization file, apply any of the rules I want to change. I haven't done any rules yet. It will combine everything into a single YAML output. And this is the thing that you can then generate with all the variables updated. And you can pipe it to another file, and then you can deploy from there. Or you can do kubectl apply -k. That's actually built-in customized. So you can do -k, and it's going to co-customize and generate this whole thing for you, and you can deploy it. But what is so cool about this? Well, let's say you're going into a QA environment, right? So right now, everything's the same. It's just dev, right? Nothing has been so much different here. So I'm going to go ahead and create a new QA directory here, right? I'm going to deploy into a QA environment. Rather than recreating the YAML file over and over again, what we can do is to create another customization.yaml. And then, let me see here, API version is customized, and kind is customization. Okay? And then I can say resources is the other files I just created. So rather than explicitly pointing to every single file, I can just give it the directory code base. Okay? And now I have this environment where I can customize stuff for QA. And then I can go to the QA environment, sorry, the QA file directory, and I can say customize build. And insofar, we're just getting the same YAML files, right? Let's do some customizations. One of the most frequently used one is changing out the replicas, right? So for example, here our deployment is only 1 copy. Let's make it 2 instead. Okay, so I'm going to do something weird here. So actually, the point here is you don't want to copy and paste the entire file, right? So let me redo that one. So I'm going to rename it. I'm going to rename it to update scale, or update replicas. Let me do that. Okay. And rather than having everything in my customized file, rather than having everything in my deployment file, I can just key it off. I can have the key, which is the API version, the kind, and the name. And then I can just keep the parts I want to change. Okay. So rather than replica is equal to 1, for this particular environment, I want to set it to 2 instead. Okay. And then if I go back to the customization file for QA, I can add something called the patch strategic merge. And then I can specify the patch file that I want to apply together with the rest of my YAML files, right? I want to actually do an edit on my YAML file, so you will. So I'm going to add update replicas.yaml. Okay? And this way, if I come back here and say customize build again, I'm going to do a less here so we can see what's being changed. Remember, we keyed it off with the kind in the API version and the name. So we're essentially editing my deployment, my demo app, and now the replicas is equal to 2. Okay? It's very, very useful. Why? Because then what you can also do is by, say, you have a different application.properties files you want to use. This is what you can do. So suppose you want to use a new application properties in your QA environment. You can create that, properties. And then I think I have a replacement here. I can override the greetings message. So I'm going to say greeting is equal to, I was in Taiwan recently, so I'm going to say ni hao, right? And then what I can do is in Kubernetes, usually what we do is we add this application of properties as a config map element. And then you have to go ahead and create that config map YAML file. Here in Kustomize, you can say config map generator. And you can give it a name. I'm going to call it the demo config, something like that. And then I can say, where is the content of this config map coming from? This is actually coming from my application.properties, right? So we can do that. And then if I go back and do another customized build, we can see that it actually generates the config map entries for me. And now that's also being part of your deployment. Okay? Now, of course, you need to do a little bit more than that, right? So this is where customization comes in really, really handy. Let me just go ahead and do another modification here. Say use config map as another patch. Remember, we're keying off of the API version, kind, and name. And then here, I think we have a template and spec. And the container name is called, what was the name of the container? I'm going to do this pretty quickly. It is called Jib demo. OK, so I'm going to do that. So Jib demo. And now I can do all the customization I want. So for example, if I want to say volume mount, so I need the volume code my config, right? Something like that. And then I'm going to get it from my config map. And there's a name. What was the name? I think it's called demo config. So I can just reference it this way. And finally, within the container, I can do the volume mount. Where do I mount this config to? Config. And then the name is called demo. It's just called config, right? And then I can override a few other things. For example, the startup arguments, I can say Spring config.location is equal to etc config application.properties. And remember, we're not touching anything that we created for dev. We're just customizing it for different environments. And this can be inherited down to different other environments too. And now if I go back to Kustomize, build, we can see that we have the config map. And if I scroll down to my deployment, we can see the replica has been updated to 2. So scroll down even a little bit more. Hopefully, we will see. Sorry. One thing I forgot is I need to add the patch merge. So I need to add here, use config map.yaml. Okay. And then I do this build again. If I scroll down, now I should be able to see the container arguments being updated, the deployment has been updated, and the volume mount has been updated, right? Okay. And then finally, I should be able to do kubectl apply -k, and this whole thing. I guess I don't have -k in my version, but you can do -k the whole thing. Or here's my favorite part. Of course, we make sure our tools work together. So rather than using kubectl to do the deployment, we can also swap this out in Skaffold, and we can say Kustomize. And where are our files? We can say this is in Kustomize /base, right? Oh, not bash, sorry, base, yeah, like that. And now, every time you do the development cycle, we're going to be using Kustomize to generate that file for you. You can even go in so far as say you can have a different profile. Name is QA. And then you can use a different deployer here with Kustomize. And you can give it the path of Kustomize /QA instead. And now you can use Skaffold to deploy your stuff into different environments as if you are doing development if you wish, right? And similarly, last point here is that in our plugin, you can also pick and choose which environment you want to deploy to. So let me try QA and see if this actually works. Maybe not, we'll see. So I'm going to do the deploy. It'll apply the customizations. So rather than deploying 1 instance, we're going to deploy 2. And we're going to have different configurations as well. And yeah, you can see we got 2 different logs here, right? So if health checks works, if this doesn't work, it will fail. And let's see here, get pods. How many people think it actually works? Nobody. That's great. We'll see. So port 8080. So I'm going to say localhost 8081 and hello name. But at least we got 2 instances. That's what I wanted. And I'm going to say Spring 1. And oh, cool. Yeah. So my application, my configuration did take. Everything has been customized for my QA environment. And you can do the same thing for other environments as well. Okay. So just a few things I were able to share. Just make sure that you go back and think about what base image you're using, what JDK version you're using, and apply some of these best practices, especially the readiness probe, and make sure you're using it the right way. And thank you so much for your time. I really appreciate you being here. Thank you.